Getting the absolute maximum speed from your linear slides isn't just a nice to have in robotics. It's often a critical advantage that can swing matches your way. Yet choosing the right motor to achieve that peak speed for your belt-driven setup can feel a bit like guesswork. This video eliminates the need for you to guess. I've systematically tested every FTC legal GoBilda motor head-to-head to show you exactly which ones delivers the best speed under various loads. This data will help you build faster, more competitive linear slides, giving your robot an edge over the competition. I'm Coach Pratt, and with over a decade as a robotics educator and having coached national champion FTC teams and Inspire Award winners, I've seen firsthand how optimizing for speed based on solid experimental data can boost a team's performance. I'm going to run you through the Misumi SAR330 test rig and show you the performance of each motor under increasing 500-gram incremental loads. By the end, you'll see clearly which RPM option provides the best speed for your slides, and you'll walk away knowing precisely which motor will give your team that critical speed advantage. So let's take a look at our testing setup here. I have 3 Misumi SAR330 slides. These are the 3-stage systems hooked up here on a belt-driven system. Down on the motor mount itself, I've got a couple different idler bearings to be able to stop this pulley from coming off. On the electronic side of things, I've got a microcontroller here running CircuitPython that has an encoder on the back of the motor so we can keep track of where our top and our bottom sections are. I'm going to have a 2-button switch that's going to be running this, and the motor itself, is going to be running off of our 2x30 amp RoboClaw controller here. I'm running it off of an FTC legal 12-volt battery pack here, so you know that the voltages we're running here should be directly applicable to our current system. On the main system itself over here, I have 2 LEDs on our screen. 1 LED placed up at the top that is green, 1 LED on the bottom that is yellow. The green one will light up when it is starting its extension. When it finishes, the green light will turn off, and then the yellow light will then turn on. It'll start its retraction, where the yellow light will then turn off at the bottom of that. And we're going to keep track of our cycle times over time on our computer here with the serial output from our board using that encoder. Couple things to note, I'm going to be making sure I'm running a fully charged battery every single test so that we get accurate results all the way across, as well as making sure the voltage is consistent across batteries. We'll run each test a couple different times, and we'll see by the end of this, realistically at different weights all the way up, how fast some of these motors are capable of doing things. So let's go ahead and get started with the first motor. All right, so kicking things off, we're starting with the 30 RPM motor. Now, this is insanity. There's no reason why you would ever do this as a realistic lift. Using linear slides as a strong lifting mechanism is likely not the best system that you can use. A linear actuator is probably more what you're doing. But just for the sake of clarity, we're going to start with this. And let's get a baseline, and we'll see just how long it takes a 30 RPM motor to bring 3 stages all the way up to 1 meter of height. You're looking about 15.5 seconds just on the extension. And 12 seconds for retractions. You got a 27.5 cycle time, or 27.5 seconds cycle time. In a 3-minute match, you're looking at 6 cycles on this. There's no way you're going to use that for any practical lifting. But let's see if it can do any sort of lifting force. So the heaviest force I have is about 9.5 kilograms. For the World Championships in 2024-25 season, the heaviest robot we saw there was about 22 kilograms. And the lightest was about 9 kilograms in total. So we're going to load up 9.5 kilograms and see if a single motor can lift that up to a single stage. I don't want to lift this up all the way up to 3 stages on 9 kilograms because that starts to get a little bit crazy. All right, so I've got 9.5 kilograms loaded up. Let's see if we can lift this up to a single stage. And you're most definitely lifting up 9.5 kilograms. You're still going to need a little bit of power to that motor so that it doesn't pull itself down after 9.5 kilograms, but absolutely 0 issues lifting that up. Let's go ahead and move on up to the next motor speed. Alrighty, so we got the 43 RPM motor hooked up here. We're still in the realm of insanity. Let's take a look at a baseline, what it moves without any load. Again, 43 RPM, you're likely not going to be using this for any sort of competition lift. As we can just how slow this is going, it's just realistically not going to happen. You're taking about 12.2 seconds on the up for extension, and about 21.75 for full cycle time. Let's go ahead and load up the full 9.5 kilos, see if we can lift it up a single stage. All right, we got 9.5 kilos loaded up here. Let's see if we can get it up a single stage. So still lots of power in that system. Let's go ahead and move on up to the 60 RPM motor. All right, so we've got our 60 RPM motor hooked up here. Let's go ahead and get what our baseline is. Again, in the 60 RPM, you're still in the realm of insanity. You're probably not going to be using this as a real lift. And your baseline's sitting at about 15.1 seconds. So getting a little bit faster there, but still a little bit crazy. Let's load up our 9.5 kilograms. We'll see if it's still capable of lifting 9.5. Almost guaranteed that it's able to. But for the sake of thoroughness, we're going to test it anyways. And so let's see if we can get a single stage. And most definitely, you're still getting a single stage on that. So let's go ahead and move on up to the 83 RPM motor. Okay, so we've got the 84 RPM motor. I believe I just said 83, but it's actually 84 RPM motor. Let's go ahead and get a baseline. Things are starting to move a little bit faster now. However, it's still really slow. Yeah, you're still looking at about 7 seconds on an extension time. Still quite slow. About 11.6 all the way across. Let's test if this is capable of lifting up that 9.5 kilos. So we've got 9.5 kilos loaded up. Let's see if we can get a single stage. And you're still coming with lots of power on a single stage. Let's go ahead and move on up to the next motor in our list. All right, we got the 117 RPM motor loaded up here. We're starting to get into some realm of sanity, but realistically, 117 is probably still a little bit slow. So let's see what we get for a baseline here. Okay, 117, you're looking at about 7.58 for a cycle time. A little bit faster, but that's still probably not enough for what you need for a robot. Let's see if we can lift up the 9.5 kilos. All right, we got 9.5 kilos loaded up. Let's see if we can lift up a single stage. And you're still... Ooh, yeah. Looks like we managed to slip a pulley on that one. I'm probably not quite enough tension on my system once I've got all of this weight loaded up on here. So let's go ahead and move on to the next weight in our, or the next motor in our system. And I will get a little more tension on my belt. Okay, we're finally into the world of sanity here. We've got the 223 RPM motor on here. This is likely if you have a robot on the heavier side and you're wanting to lift yourself up. So let's go ahead and see what a base cycle time is on this. Okay, you're looking at about 3.92, 3.93, somewhere in that realm. Still not the fastest in the world, but if you maybe have a really heavy implement on the top, you may consider using one of these. Let's see what 500 grams does for us. $500 grams basically nothing, 3.99, 3.94, somewhere around there. Let's go ahead and move on up to a kilogram. See what we get on that. And barely even breaking a sweat at 3.99, 4.0, 4.01, somewhere around there. Let's move up to a kilo and a half. Definitely up and down reliably, 4.05, 4.06. Let's move up to a full 2 kilograms. Still quite reliable, about 4.1, 4.12, somewhere in there. Let's move up to 2.5 kilos. And still going quite quick at 2.5 kilos. Not really feeling anything there. Let's move up to 3 kilograms. You're slowing down quite a bit, 3 kilograms. I think realistically I'm going to stop out the test there. All right, so let's move on to some lifting tests here. I've got 4 kilograms loaded up. Let's see if we can get up a single stage. And no issues on a single stage. Let's see if you're going to get 5 kilograms on a single stage. No issues with 5. Let's move up to 6 kilograms. Slowing down a bit at 6. Let's go on to 7 kilograms. Still going strong at 7. Let's move up to a full 8 kilograms. Ooh. Starting to struggle at 8. Let's move up to 8.5 and see how that goes. I think I'm going to slow down my down speed there. You're still moving strong at 8.5. Let's move up to the full 9.5 kilos. Ooh. And you're still moving a single stage at 9.5 kilos. Let's go on up to our 312 RPM motor. So we're finally into the realm of sanity at the 312 RPM motor. This is realistically probably one of the first motors you're probably going to grab when you think about moving a linear slide up and down. So let's go ahead and get a baseline. Okay, you're looking at a cycle time of about 2.95, 2.96, somewhere around there. Let's see what we do when we hit 500 grams. And barely feeling that at 2.98, 2.99. Let's move up to a kilogram. About 3.08 on a kilo. Let's move up to a 1.5 kilos. And still quite quick at about 3.16, 3.15. Here we've got 2 kilograms loaded up. Let's get a baseline. Looking at about, let's do one more. Hey, we're sitting about 3.21, 3.22 on a cycle time. Let's see what 2.5 kilograms brings us. Okay, you're going about 3.34. Let's move up to 3 kilograms. Realistically, starting to struggle around 3 kilograms. We're going to stop there at about 3.5 seconds for a cycle time. If you are lifting an element that is 7 kilograms between 2 motors, or you're trying to lift your entire robot up 3 stages on a 312 motor, you might be able to do it, but it's going to be real slow. So let's go ahead and start doing some lifting tests and see if we can get up a single stage on some of these. So we're moving up to 4 kilograms for our first lifting test here. And you're definitely lifting 4 kilograms. Load up 5 kilograms here. And you're definitely getting 5 kilograms. Let's move up to 6 kilograms. Oh, starting to struggle a bit at 6 kilograms. Let's see what we get on 7 kilos here. Well, 7 kilos is definitely feeling it. Let's see if it's capable of doing 7.5 kilos up a single stage. Oh, still lifting 7.5 kilos up a single stage. See if we can do 8 kilos up a single stage. Oh, you can still do it, but it's really struggling at 8 kilos. All right, so that's the end of our 312 RPM motor test. Let's move on up to our 435 motor. Alrighty, so moving on up to the 435 motor. This may be one of the most practical motors to do because it has a really nice balance between lift and speed, or lifting strength between speed. So let's go ahead and get a baseline and see what we come up with. So it looks like our baseline is looking at about 2.02. Let's load up 500 grams and see where we go with that. Yeah, baseline about 2.08. Let's move to a kilogram. One more. Hey, you're getting a baseline about 2.16. Let's move up to a kilo and a half. Okay, let's see what a kilo and a half does. We're sitting about 2.21 as the cycle time. Let's move up to a full 2 kilograms. Ooh, we're starting to struggle a bit now. Yeah, 2 kilograms, look about 2.35, 2.36. Let's go to 2.5 kilograms. Ooh, really struggling at this point. Okay, we're looking at about 2.5, 2.51. Let's move up to 3 kilograms. Oh, still lifting up 3 kilograms, but I don't think realistically you're going to get much speed out of that. 2.72. Let's go to 3.5. You're still lifting 3.5 all the way up at about 2.98. That's pretty impressive. Let's go ahead and load up 4 kilograms. This will probably be our last test at this point. And you're sitting about 3.34 as a cycle time of 4 kilograms. At this point, let's go ahead and test if we can do some of that lifting. So let's do 4.5. Look, we lift 4 all the way up to the top. We're only going to go through 1 stage on these ones again, just because it ends up being a lot of pressure all the way down. So let's just see if you can lift up a single stage. And you can definitely lift up a single stage at 4.5 kilograms. Let's see if you're going to get a single stage at 5 kilograms. You're definitely going to get a single stage at 5 kilograms. Let's try 6 kilograms. What? Really struggling at 6 kilograms, but you're still able to do that. This is 6.5 kilograms, so let's try this out. Oh, you're really struggling at 6.5. But you're still able to lift up about a single stage. But I think 6.5 kilograms is likely where you're going to max out on a 412 motor. So let's load up the 1150 and see where we can go with that. All right, so let's take a look at the final motor in the test here. This is the 1150. So let's go ahead and get a baseline. Looks like we're baselining at about 0.85, 0.83, somewhere in that realm. Let's say about 0.85. Let's load up 500 grams, and let's go ahead and get a baseline at 500. Okay, so let's go ahead and get a baseline at 500 grams here. Looking at about 0.93 upwards of 0.96. So let's say put 0.94, 0.945. Let's go ahead and load up a kilogram and see what that does. Okay, so we've got a kilogram loaded up. So let's go ahead and see how this performs. Okay, we're looking at about 0.11, 0.13. So let's say about 0.12 on a kilogram. This is already looking a lot more consistent than when we had our string slides moving up about a kilogram. We can hear that things aren't really working as hard on this one. So now that we've got all the data across all of our motors, I think we're going to stop out at about a kilogram. I'm not sure. Well, let's try 1,500. Alrighty, so we got about 1,500 grams loaded up on here. Let's go ahead and see what our cycle times are. Whew, that's real slow. And we're sitting at about 1.48, 1.51. Let's go ahead and say about 1.59 or 1.49. Go ahead and stop at 1,500 grams. I think it's going to max out for our motor there. And at this point, we're now done with all of our tests, the 1150. So let's go ahead and look at all the data to see how our belt slides performed. So when we look at this data all together aggregated, let's see what kind of recommendations we can make off of these. We look at these zero load cycle times of our kind of high torque motors from 30 through 117. You go from about 27.5 seconds all the way down to 7.5. When we look at the max weight or the load that you can lift up a single stage, all the way up to 223 RPM, you're lifting 9.5 kilograms. So there's realistically no reason for any sort of speed on a linear lift that you should ever be using anything less than a 223 RPM motor. You can lift 9.5 kilos. You put two of these things on there, you're going to be lifting 18 kilos, give or take. You're probably going to lose a bit of force. You can't really assume perfect force transfer when you add two motors on. So let's just assume 18 kilos, take off a kilo of lift. That's probably too much, but realistically, you shouldn't be using any of these higher torque motors, 30 through 117. When you look at something that starts to get lifting heavier up a single stage, you can lift upwards of 6,500 grams on a 435 system. So these things can still pick up quite a bit of lift. So let's compare all the motors across each other to see what ends up shaking out. It really depends on just how much lifting force that you're going to have to apply. Now, it looks like at some point across all these systems, there is no crossover point. So what I mean by crossover point is, for instance, when we get at 2,000 grams, there's no point in here that 2,000 grams actually performs worse than a 312 motor does. So as we decrease or as we increase the RPM of our motors, we are just simply increasing our speed all the way up to about 3,000 grams. So it depends on how heavy that implement where you're going to be putting on top of that output is. Now keep in mind, these are max systems on here. I did not test 3,000 grams on the 312 motor. I probably should have. In fact, would probably limit out. You probably could have gotten about 3,500 grams, but again, on that single torque system, or on the single supported system, I didn't really want to push too much. And realistically, if you're loading up 6 kilograms on an outtake or on that implement between your linear slides, you've probably got too much weight on there anyways. So realistically, you're probably going to be in this anywhere from this 500 grams all the way up to about this 2 kilogram section. And again, keep in mind, this is one motor. If you were to have two motors on here, you're not going to double the force, probably about 1.8, 1.9%, or 1.9 times, 1.8 times. So realistically, this 500 gram should actually be, a 900 gram output system. So you probably want to be looking more on the bottom half of this chart when we're looking across these. So probably about 2,000 grams and down, depending on just how beefy that elevator is on yours. So on these recommendations, the 1150 looks like a pretty solid motor. Now, again, you start to get the law of diminishing returns as you go lower. So yes, a 2-second cycle time versus a 1.12 second cycle time. Yes, it's twice as fast. It's a full second difference. However, you have to keep in mind, it's faster, but is it practical? Is it pragmatic? Does that second actually matter? Because you've got that issue where if you have your robot has to get an implement from here to another point on the field, and it takes more than a second for you to get between those two positions, does that second cycle time actually matter? Likely not. In that case, you could use a 435 motor, and then you could realistically lift your robot up a little bit when it comes to some sort of hanging mechanism, if the game for the year happens to have a hanging mechanism. So you really have to make some of these pragmatic decisions between these two. Also keep in mind at the 1500 gram point, the 1150, it's probably pulling more current to be able to lift that up at that point, whereas the current on the 435 is probably not near as high because you don't need as much torque to be able to get that out, because there's a pretty significant difference between the torque output on an 1150 motor versus a 435 motor. And we can see that when we look at these motors, when you start to get to the point where it really starts to torque out on them, there's a pretty significant jump in that trend line. Right about the midpoint here, there's a pretty large significant jump there. Right about here, there starts to get a pretty large jump. Right about 1500 grams, there starts to get a dramatic increase. And on the 1500, probably about 750 grams, there's a pretty dramatic increase in the amount of torque that's applied. So you have to think about the amount of current that your motors are going to be pulling as well, because that's really going to affect how well these things are going to perform too. Sort of flat recommendations, kind of hard to make. It depends on the game. If you need absolute speed, obviously 1150 is the way to go, but you're going to have to make some other design constraints around that. You're not going to be able to lift your robot up with a couple 1150s. You're likely going to need some sort of power takeoff where you can have a system that will connect your lifting motors to your driven motor so that you can pull your robot up from that point. 435 is probably a really good all-rounder for linear slides. There's a good balance between speed and torque. But you are going to have to think about, with that increased speed, you're going to have to make sure that your system is far more reliable, because you're going to need those belts to stay on the entire time. As you're going faster, you start to reduce some of that tension on that belt as you're pulling in other ways, and you're really going to need some of those idlers. If you're looking for a system like mine that works pretty reliably, I've got a video in the description down below. Other than that, I hope you found this a really helpful video in looking at your comparisons between which motor should you use for your belted linear slides. These experiments take me a lot of time to set out, and I hope you find them helpful. If you did, please consider giving me a like, and if you want to see more robotics tutorials in the future, consider subscribing as well. Best of luck on your next robotics project.